For those of us who feel that algebra has no place in our everyday lives, or those who never really grasp the basic concepts of algebra, then this video is for you. In this video, we'll explore 3 real-life examples in which algebra plays a key role, even though you may not realize it. All that, coming right up. If you'd like to learn more about equation manipulation, please stick around for the 3rd and final example in which we'll take a deeper dive into that topic. And if you find this video helpful, please like and subscribe. And remember to click the notifications bell so you'll stay up to speed on all new future videos. Simply put, algebra can be used to quantify the relationship between one value and one or more other values. One way to understand the concept of algebra is by starting with a quantitative question and then translating the question into an algebraic equation. In our first example, we'll look at a common activity we all perform nearly every day, namely buying things. It involves a very basic use of algebra. When we buy a product or service, we usually pay the base price plus a sales tax. We know the sales tax percentage, say 6%, but not necessarily the amount of sales tax. If we buy 2 products and the base price of one is $12.98 and the base price of the other is $25, we can ask ourselves the following 2 questions. What is 6% of $12.98, and what is 6% of $25? So, in our purchasing example, we have 2 values that can change, namely, the price, and the answer to our question, which is, what is 6% of our base price? These changeable values are called variables. The sales tax of 6% is a fixed value, so we don't have to assign a variable label to it. So, how do we convert our 2 questions into algebraic expressions? To do this, we can label the price as x, and label the answer to our question as y. The answer to our question, y, depends on the price, x, so y is referred to as the dependent variable and x is the independent variable. Percent is a combination of 2 words, namely, per, or divided by, and cent, which stands for 100, as in centimeter, which is 1/100th of a meter. So, percent means per 100, therefore, 6% is 6 divided by 100, or 0.06. Therefore, our algebraic equation can be expressed as y equals 0.06 times x. In this example, the sales tax for the first product is 0.06 times $12.98, which equals 78 cents, and the sales tax for the second product is 0.06 times $25 or $1.50. By converting our question into a generic equation, we can use the equation to determine the amount of sales tax for multiple products with different base prices. We can even go further by expanding the equation to add the sales tax to the base price, giving us the total cost of the item. The expanded equation would be y equals x times 0.06 plus x, where y equals total cost, and x is the base price. This equation can be simplified as y equals x times 1 plus 0.06, or y equals 1.06 times x. Next, let's turn our attention to another real-life algebra application, namely determining how much pizza to order for a party. Let's say we need to order enough regular crust pepperoni pizzas for 12 people, and each guest is expected to eat a maximum of 4 slices of a medium pizza. Each medium pizza consists of 8 slices. So, to convert this problem into an algebraic equation, we could express the problem in the form of a question by asking ourselves how many medium pizzas would be needed to accommodate our guests. The answer to this question will depend on the number of guests, the number of slices per pizza, and the maximum number of slices each guest is expected to eat. We can assign the variable label y to the answer to our question, which is how many medium pizzas are needed. The independent variable, in this case, is the number of people, which we will label as x. The number of slices per pizza and the maximum number of slices that each guest is expected to eat are fixed in our example, so we won't assign variable labels to those values. The equation we wind up with is y equals 4 times x divided by 8. In this equation, 4 times x is the total number of slices to be eaten, and 8 is the number of slices per pizza. Entering the variable values into our equation gives us y equals 4 times 12 divided by 8, or 48 divided by 8, which equals 6 medium pizzas. We can now use this equation to determine the number of medium pizzas needed for any number of guests. That brings us to our 3rd and final example. In this example, you're going on a road trip, but your friends left before you because you had some errands to run before you could leave. You plan to follow the same route as your friends. When you set out on your journey, you call your friends to let them know you're leaving. They tell you they've already driven 100 miles and they estimate that their average speed will be 40 miles per hour for the remainder of their 800-mile drive. You plan to drive at an average speed of 50 miles per hour and you ask yourself, will you catch up with your friends before they reach the final destination, and, if so, how many miles will you have driven when you catch up with them? As you'll see, this problem involves only one variable, but it will appear on both sides of the equation. The fixed values we know are your planned speed, your friend's estimated average speed, and the distance your friends have already traveled at the time of your departure. We also know that the total distance to the final destination is 800 miles. The answer we're trying to solve for is the distance you need to travel in order to catch up with your friends. So, let's label that unknown as x. Distance divided by speed equals time. Specifically, miles divided by miles per hour equals hours, because miles, which are in both the numerator and denominator, cancel each other out, and hours, which are the denominator of the denominator, move up to the numerator. If you and your friends simultaneously start timers at the time of your departure, the elapsed time will be the same for both you and your friends when you catch up with them, that is, unless one of you is traveling at the speed of light. We can use this fact to create an equation. When you catch up with your friends, your elapsed time, which is your distance traveled divided by your speed, will equal your friends' elapsed time, which is their distance traveled divided by their speed. But remember, they've already traveled 100 miles, so we'll have to subtract that from their distance traveled. So, the equation we end up with is x divided by 50 equals x minus 100 divided by 40. To solve for x, we need to get the x's on one side of the equation. We can start by multiplying both sides of the equation by 50, in order to cancel 50 in the denominator on the left side of the equation. Next, we can divide 50 by 40 on the right side to get 1.25, and then multiply that across both terms in the parentheses. Next, we can subtract the term 1.25x from both sides to get both x terms on the left side. We can then pull the x variable out on its own on the left, and then divide both sides by the entity in the parentheses on the left to get x all by itself on the left. Now we can solve for x, which turns out to be 500 miles. So, you will catch up to your friends after traveling 500 miles. To find out how long it will take you to travel 500 miles, simply divide 500 miles by your speed, 50 miles per hour, and you get 10 hours. Thanks for watching. If you enjoyed this video and want to see more like it, please like and subscribe. And to avoid missing out on new videos, please click the notifications bell. Have a great day.